means vector space means let us start with any non-empty sets which are denoted by V, which is a non-empty set, and you can take any field. Is it audible? F is a field. You can take any field which are denoted by F, right? If there exist two operations, one is this operation from V cross V to V. Second is another operation from field F cross V to V. That means you started with any vector alpha comma beta. This alpha plus beta should be element of V. And you take any scalar and any vector that maps to V. That is denoted by A into alpha. So there are two operations. One is this, one is this. So with respect to first operations, satisfying the following properties. First one is with respect to first operation, V must be a abelian group. Right? With respect to first operation, in group theory we have completed, in fact. So abelian group, So with respect to this operation, first operation, it should be a abelian group. And with respect to second operation, in fact, it's a function. Means what? You take any scalar and you can take any vector that that map A into alpha should be an element of alpha. That means A into alpha should be an element of V whenever A belongs to scalar and you take any vector which is in V. That means it's a map. Simply it's a map. This is a map. Right? So this is my second property. Third property is with respect to second operations and first operation, we start with any two elements which are in field, right? A plus B into alpha is equals to A alpha plus B alpha, which is true for any two scalar A comma B or any two scalars and alpha in any vector. And A into B into alpha is equals to A into B alpha. This is true for any two scalars and any vector. Right? And next is we take any scalar, you take any two vectors. A into alpha plus beta is equals to A alpha plus A beta. This is true for any scalar and any two vectors which are in V. Next, last one into alpha, where what is meant by one? One is an identity element in F. What is F? F is a field. So 1 into alpha, this operation is this operation. This operation. But this is another operation. So this operation is that operation, scalar multiplication. 1 dot alpha is equals to alpha for any alpha belongs to V. Right? If there exist two operations with respect to which V is with respect to first operation, V is an abelian group. With respect to second operation is a function. Second operation is a function. And third one is, so this satisfying the four properties. Then one can say that V with respect to addition and multiplication is nothing but a vector space for a field F. Simply one can write V is a vector space for a field F. Right? So with respect to first operation, V is an abelian group, and V satisfying this operation which we call it as internal operation. Why? Because you take two elements which are in V, that alpha plus beta should be in V for every alpha comma beta belongs to V. That means you take two elements which are in V, in internal, that alpha plus B should be in V. What is scalar multiplication? You know, what is this operation? This is nothing but external operation. External operation. That means you take any scalar, which is in, from the field, and you can take any vector. That scalar multiplication should be in a vector, should be a vector. That means it's a external operation, because one is coming from the field, one is coming from a vectors. Therefore, this is nothing but a external operation. This operation is nothing but a external operation. This is nothing but internal operation. Right? Just wait. Operation is an abelian group. With respect to second one, is a, it satisfies the scalar multiplication property. This is a scalar multiplication property, and third one holds. Then one can say that V is a vector space. The elements which are coming from V here are nothing but vectors. The elements in V are nothing but what? Vectors, which are denoted by letters in general. And elements coming from the field are scalars. In general, I can denote these scalars by ABC, small ABCD. Right? Suppose you can take this an example. Suppose you can take R2, V is equals to R2, my F is equals to real field. Right? In order to define a vector space, what I require two operations. One is this, one is this. One is internal, one is external operation. So vector addition means internal operation, which I denoted by like this. Vector addition. So you can take any vector. So what is my R2? You know, R2 is nothing but what? R2 is nothing but set of all order pairs. Each element should be a real number. Right? So you take any two elements, x1, x2, y1, y2. This is my addition. This is my operation on V. What is this operation? This is an operation. Addition is nothing but here. This addition represents operation on V. First operation, internal operation. This I denoted by like this. Like you can take this x1 plus y1, x2 minus y2. This is my operation for any two elements. x1 comma x2 belongs to V, and y1 comma y2 belongs to V. And second one is what? External operation. What is the external operation? Means scalar multiplication.
Plus sir. x2 plus x2 plus y2.
Yeah, నేను అక్కడ డైరెక్ట్ ఇయర్లేని ఎగ్జాంపుల్ కాందిస్తున్నాను. ఓకే, ఇష్టం ఇది వెళ్ళి పని అయితే చాలు. వెక్టర్ స్పేస్ అని నేను చెప్పట్లేను, ఇట్స్ అన్ ఆపరేషన్ అంటున్నాను.
ఓకే ఓకే సార్.
ఓకే, సో therefore x1 comma x2, which is defined by, it is a scalar. This is a scalar, this is a vector. This is scalar, this is a vector. Therefore this operation is which is defined by, you can take ax1, ax2. Question is that, is it a vector space? Is V a vector space? Right? Vector space or a field? What is my field here? Or is it a vector space? Right? The answer actually, so first question, to answer this question, actually, first of all, is it actually operation? Is first of all, what I need actually two operations. In fact, operation is nothing but what here? In fact, it's a function from V cross V to V. Secondly, also operation means what? It is also function. There exist two functions, in fact, operations. Right? So here, question is that you take any two elements, x1 comma x2, and this is my another element y1 comma y2. What is my addition operation here? X1 plus y1 comma x2 minus y2. Question is, you give me any order pair. It is an order pair. It is an order pair. You know, this is an order. This is an element which is in R, right? Why? Because x1 comma x2, y1 comma y2 are the elements in R2 R. Therefore, this sum also element in R. This subtraction also element in R. Therefore, each component is an element of R. Hence, it is an element of R2. Therefore, whatever element you give me in R2 cross R2, you know, we can have an element in R2. You give me any element here, x1, y1, x1, x2. You give me any element y1, y2. Their vector addition is a clearly is a order pair, right? That is denoted by x1 plus y1, x2 minus y2. Therefore, clearly it's an order pair. Therefore, hence it is a function, right? Therefore, it's an internal operation is well defined. It's meaningful, right? Question is that operation is well defined? Yes, because give me two order pairs. Their addition is also an order pair. Hence, it is a well defined operation, right? Question is that is it in with respect to first operation? What I require is that is it an abelian group or not? We with respect to addition with this operation, is it an abelian group or not? You need to check all the properties. Question is that is it an abelian? In fact, is it closed? Okay, is it an abelian?
No.
No. Suppose you can take alpha is equals to 1, 2. So clearly it's an element of V. Beta is equals, you can take anything, 3, 4, right? Question is that alpha plus, does it mean that alpha plus B is equals to beta plus A, alpha? You need to check it. What is alpha? 1, 2, 1 comma 2 plus 3 comma 4. That means, what is my definition? 1 plus 3 comma 2 minus 4. That means 4 comma minus 2. And what is beta plus alpha? Beta plus alpha is equals to 3 comma 4 plus 1 comma 2. What I mean is 3 plus 1, 4 minus 2. That is equals to 4 comma 2. Therefore, we observe that these two are differ. Therefore, alpha plus beta should not be should not be same as beta plus alpha. Therefore, it's not an it's not an abelian group, right? It's closed. Okay. In fact, I don't know whether it is group or not. I don't want to check all the conditions. So V, it is closed with respect to addition. Okay, it's an vector addition with respect to addition, closed. Okay, but the thing is that this property fails. Alpha plus beta is not same as saying that beta plus alpha. So therefore, it's not a vector space. No need to check all the conditions. Understand? Is it clear?
Yes, sir.
So therefore, next one is, suppose you can take this same one, V is equals to R2, F is equals to R. Therefore, my vector addition is defined by like this: x1 comma x2 plus y1 comma y2 is equals to, my definition is like this: x1 plus 2y1, x2 plus y2, and scalar multiplication is defined by like this: a into x1, a into x2. Question is that, is it a vector space or a field R? Question is, first of all, is it a well-defined function? First one, the answer yes, because you give me any two elements, x1, one is x1, x2, second is y1, y2. If you add them, what is my this? It is a real number, no doubt, and it is also x2 plus y2 also real number. Therefore, hence it is an element in V. Therefore, this vector addition operation is meaningful operation, right? This vector addition operation, it's an operation, right? This operation is meaningful because you give me two elements which are in R2. Once you add them, you are going to have a vector in V. Therefore, it is a meaningful operation, no doubt. Question is that with respect to this operation, is it a abelian group or not? You need to check it, right? So first of all, you need to check that first you need to guess it. So x1 plus 2y1 is there, x2 plus 2y2 is there. You need to guess that it fails to satisfy the abelian property, right? So I can guess that alpha, I can take alpha is equals to 1, 2. You can take alpha beta is equals to some 3, 4. What I guess is that alpha plus beta is nothing but, what is alpha plus beta? 1 plus 2y1, 1 plus 2y1, and 2 plus 4. That means 7 comma 6. Right? Next, what is beta plus alpha? Beta plus alpha is equals to 3 plus 2y1 into 4 plus 2. That means 5, 6. Therefore, these both are different. Therefore, alpha plus beta should not be same as saying that beta plus alpha. Therefore, it fails to satisfy the abelian group property. Means it's not a, so I don't know whether it is a group or not, you need to check it, but it fails to satisfy the abelian property. Means alpha plus beta should not be same as saying that beta plus alpha. Therefore, hence it is not a vector space. Right? Right. Suppose you can take V equals to R2 and your field is real numbers. Question is, suppose you can take this x1 comma x2 is the vector, y1 comma y2 is another vector. My definition is this one, x1 minus y1, x2 minus y2, and this is nothing but a into x1 comma x2 is equals to ax1 ax2. Question is that, is it a vector space? Is V a vector space?
Yes.
Yes, or a field left?
Yes.
Is it yes or no?
Yes, sir.
No, right? Suppose if you take this alpha is equals to, first of all, it is closed, okay, because it is each order pair, it's an order pair. This total is an order pair, hence it is a it's an operation, internal operation, no doubts. Question is that if you take alpha is equals to 1, 2, same thing. If you take beta is equals to 3, 4. Question is that, does it mean that alpha plus beta is equals to beta plus alpha?
No, sir.
No, right? So therefore alpha plus beta is different from, what is alpha plus beta? This minus this, minus 2, 2 minus 4, minus 2. So alpha plus beta is equals to this. What is beta plus alpha? Beta plus alpha. What is beta plus alpha? 3 minus 1, 2, 2, 2. Therefore, which are not equal. Therefore, alpha plus beta are not equals to beta plus alpha. Hence, it is not a vector space. Right? So now we can take this. V is equals to R2. So my operation, first operation, internal operation is like this. This x1 plus y1, next x2 plus y2. Right? Second operation is denoted by like this, a into x1 comma x2 is equals to, suppose we can take this ax1 comma 0, where a is a scalar and these are the vectors. Question is that, yeah, now my question is that, is it a vector space?
Yes.
Yes.
Yes, sir.
Or a field R? Is it yes?
Yes, sir.
Who say yes?
It will be a abelian group.
Yeah. Is that okay for a vector space? Is there only one first property? Is that first property means first condition okay for a vector space?
4 conditions.
Yeah, it satisfies that all of the 3 properties, right? It should be abelian group with respect to addition, and it should, it should hold scalar multiplication property, and the whole last 4 properties should hold, right? Okay, the thing is, first one, there is no problem with abelian group, right? Why? Because it's simply usual addition, component wise addition. X1 comma x2, y1 comma y2 is equals to component wise addition. Means this one is x2 plus y2, component wise addition. This plus this, this plus this. So there is, when you have a component wise addition, there is no problem. You need to check that. You need to simply inquire that it satisfies all the property. It is closed with respect to addition. It satisfies associative property. What is an identity? It is closed. Yes or no? It is closed. No doubts. Is it associative?
Yes,
Is it
sir.
associative? Yes.
Yes, sir.
Right. Automatically it is associative. You need to check it. Simple properties. You need to check it. Y1, y2 plus z1, z2. So it is associative. What is an identity element?
0,
0, 0. Right. Right. What is an inverse of the element x1, x2?
minus x1, minus x2.
Yeah, minus x1, minus x2. It's an inverse. Right. Of course, it is an abelian group. No doubt, because it's a component of the addition. Right. So first, there is no problem with first property, means since it is no, it's an abelian group. Now look at the property number 2. Yeah, question is, you give me any scalar, you give me any vector. If you scalar product them, what you get is, again you can have a order pair. It's an R2. It's an element in R2. That means it's an element in V. So there is no problem with scalar products, scalar multiplication. You give me any scalar I, you give me any vector, you scalar product them, and you can have a vector which is in R2. Therefore, there is no problem with second property. Now look at the property number 3. Right? Look at the property number 3. So what is my guess is, suppose I can take A equals to 1. So what are my properties? You need to keep in mind whether suppose you want to check whether it is a vector space or not. You need to keep all the properties in your mind. So what are the 4 properties? So last property, what is the last property? Suppose I have a identity element 1 into alpha is equals to alpha for every alpha belongs to V. I need to check this. Right? Suppose I can take alpha is equals to 1, 2. So clearly it's an element in V, no doubts, because it's an R2, it's an element R, it's an element R, therefore it is an element of R2. Now 1 dot alpha means what? What is the definition? 1 dot 1 comma 2. That means what? What is my definition? A into X. 1 into 1 comma 0. That means 1 comma 0. Is it equals to alpha? Is it equals to alpha?
No, sir.
No. Therefore, 1 dot alpha should not be equals to alpha. Therefore, there exists at least one element. There exists at least one element in such a way that 1 dot alpha should not be equals to alpha. Therefore, it fails to satisfy at least one of the property in a vector space. Therefore, hence it is not a vector space. Right? Therefore, it is not a vector space. Right? Suppose you can take this. Suppose you can take this V equals to R2. My field is F is equals to R2. My vector addition is this x1 comma x2. It's an visual addition because I'm getting different problems by defining different operations. So this is usual. You know what is the problem if I define different ways, right? This is a vector addition. What is scalar multiplication? Suppose you take this 0 comma ex2. Is it a vector space?
No, sir.
No.
The same idea, right? The same idea. It is an abelian group. There is no problem, and it satisfies the scalar multiplication property. No problem. Second property also trivially cold. The problem with only third property. In fact, it fails to satisfy that 1 dot alpha is equals to alpha. Therefore, it is no, because 1 dot alpha may not equals to alpha. Is it clear? Suppose you can take this V equals to R2, F is equals to R. Right? Suppose you can take this vector addition. My definition is y1 comma y2 is equals to, suppose I fix this vector addition because I know if I choose different operation, it is not a vector space. So this is fixed. Vector addition is usual component wise addition. Suppose my scalar multiplication is defined by like this. You can take this. Suppose what I choose, a square x1, a square x2. Yeah, is it a vector space? Is V a vector space?
Yes, sir. Last property will satisfy.
Does it satisfy last properties? So there is no problem with first property. We should, with respect to addition, this operation is an abelian group. There is no problem. Right? Is an abelian group. There is no problem. What is my second property? Automatically, you give me any scalar, real scalar, you scalar product them. What you get is a square x1, a square x2. It is also element of V. There is no problem. So what about the third property. So in third property, there are 4 properties. Right? Suppose I can choose A equals to 1, B equals to 2, alpha equals to 1, 2. Does it mean that A plus B into alpha is equals to A alpha plus B alpha? So what is A plus B alpha? A plus B alpha. What is A plus B alpha? Anybody? 1 plus 2 into alpha. That is equals to 3 into alpha. Means 3 into what is alpha? 1 comma 2. That means 3 square into 1, 3 square into 2. That means 9 comma 18. So left side is 9 comma 18. What about right side? What about right side? A means 1 into alpha. Next, what is beta? What is B? What is B? B is equals to this. So therefore, what is the definition? 1 square 1, 1 square 2. Next, 2 square 1, 2 square 2. That means, 1 square 1 means 1 comma 2 plus 4 comma 8. How I define vector addition? It is a vector addition.
5, 10.
It is a vector addition. So how I define vector addition? Component wise addition. It is component wise addition. So right. So therefore, this is nothing but what? 5 comma 10. Are they equal? 9 comma 8, 5 comma 10? 9 comma 18 and 5 comma 10. No, right? So therefore they're not equal. Therefore it fails to satisfy one of the third property. At least one of the third property. Therefore, it's not a vector space. So suppose if I take a cube, suppose you can take instead of taking a square, you need to take suppose v equals to r2, f is equals to r. Suppose my vector addition is like this: x1 comma x2 plus y1 comma y2. It is fixed. x1 plus y1, x2 plus y2. Just what is scalar multiplication? A into x1 comma x2 is equals to mod a x1 mod a x2. Question is it a vector space or a field R? Yeah, anybody? So there is no problem with first and second property. We have seen. It is a abelian group with respect to
No,
addition,
sir, no.
right? Yeah. Which property fails?
A plus B dot alpha only, sir. If it is a negative number.
Yeah.
Mod
Yeah. A equals to 1, B equals to -1, alpha equals to 1, 2.
mod
Right. Yeah. A plus B into alpha. What happens? What is A plus B?
B alpha plus B alpha.
What is A plus B? First of all, this is
0.
0. 0 into 1 comma 2. That means mod 0 1 mod 0 2. That means 0 comma 0. So left side is 0 0 0 vector. What is right side? A alpha B alpha. What is A? 1 into 1 comma 2. What is B? -1 into 1 comma 2. This is nothing but mod 1 into 1 mod 1 into 2 plus mod -1 into 1 mod -1 into 2. That means 1 mod 1 means 1 1 into 1 is 1 mod 1 is 1 1 into 2 is 2 plus mod 1 is mod -1 is also 1 1 into 1 is 1 mod -1 is 1 1 into 2 is 2. So 1 1 1 2 1 2. That means what? 1 plus 1 2 plus 2. That means 2 comma 4. So are they equal? No. So therefore A plus B alpha should not be seen as saying that A alpha plus B alpha. Therefore it fails to satisfy this one of the property of 3. So therefore it is no. Right. Next one. Suppose you can take this V equals to R2, F is equals to R. My vectorization is this. X1 plus X2, Y1 plus Y2, and we take a scalar multiplication is like this. This is defined by, so we have seen a square and x1, a square x2. What about a cube x1, a cube x2? Anybody? Is it a vector space? Anybody?
No, sir.
No. Yeah, which property fails to satisfy? Give me, whenever you say yes, give me counter example.
Third
one?
property, sir, A plus B alpha.
Yeah, in third property there are 4 properties. Which one? First one, second one, or third one? Fourth one. Which one? Give me vector, give me scalars. Random checking, right? You can check. Suppose you can take all a equals to 1, b equals to 2, alpha is equals simple 1 comma 1, 1 comma 2, or else. The clearly all the elements meaningful. Therefore, what about a plus b alpha? A plus b is 3 into alpha means 3 cube into 1, 3 cube into 2 means 27 into, what is that? 27 2 means 54. Left side is this. What about right side? So 1 into 2, 1 into 1 comma 2, and 2 into 1 comma 2. What is this? 1 cube into 1, 1 cube into 2, plus 2 cube into 1, 2 cube into 2. Therefore 1, 2, this is 8, 16. Right? This is 9, this is 18. Are they equal? Are they equal?
No, sir.
No. Therefore a plus b should not be equals to alpha, should not be equals to a alpha plus b. Therefore it is no. Right? So I hope you understand. What is the troubling? What is the troubling you are getting? When I use, vector addition in different, your vector addition in different case, it is not a vector space. x1 minus y1, x1 minus x2 minus y2, x1 plus 2y1, x2 plus 2y2, right? X1 plus y1, x2 minus 2y2. So in all cases, what you observe, when you define vector addition in different manner, it's not a vector space. You may guess, right? When I define scalar multiplication in different manner, when I define a vector addition is okay, a component wise is okay. When I define a scalar multiplication in a different manner, it is not a vector space. So what is the troubling you're facing? In all of the examples, you observe that when I define vector addition and scalar multiplication in different order, other than component wise, it's not a vector space. Therefore, no. To change that idea, what I do is I take this v equals to r2 and f is equals to r. You take x1 comma x2. This is y1 comma y2. This is component wise. You fix it. X1 plus y1, x2 plus y2. If I define this is in different manner, it is not a vector space we have seen. And x1, x2, if I define it in different manner, it is also a vector space we have seen. Just last examples. So what I do is that it is also component wise. Ax1, ax2. It is also component wise. So therefore, if I define this, question is that is it a vector space? Over a field of, is it a vector space?
Yes, sir.
Yes, sir.
Yeah, all the properties you need to check it. Already we've seen the first property. We have checked, it's an abelian group, no doubt. What is my second property? Automatically it is it satisfies the scalar multiplication because we take any scalar, it is a scalar, it is a vector. Automatically scalar multiplication, it is also a vector. What is the third one? We take any two scalars, a plus b into x1 comma x2. When you do this, what is the definition? A plus b into x1, a plus b into x2 by definition. This can be rewritten as ax1 plus bx1, ax2 plus bx2. Again, by vector addition definition, when you have like this, you can split into two order pairs. So therefore, you can split by the definition of vector addition. You can split it into two pieces, two order pairs. Again, by definition of scalar multiplication, when you are given like this, right side, you can write in the form of a into this. Therefore, a into x1, x2, b into x1, x2 by using the definition of scalar multiplication. Similarly, one can easily check it. AB into x1, x2 is equals to, once easily check it. One can easily check it. This it's an exercise. So it is automatically hold by definition of this same thing. And a into alpha plus beta is equals to a alpha plus a beta. It also clearly hold. And 1 dot alpha. What is this? 1 dot x1 comma x2. By definition, 1 into x1, 1 into x2 is nothing but x1 comma x2. That is equals to alpha. Therefore, all the properties hold. Therefore, V is a vector space for a field R. Is it clear? Okay.
Yes.
Suppose you can take this 9th example. 10th, if I take V equals to R2, okay. If I take F is equals to, complex field. If I take my field as a complex field, the vector addition is same. X1 plus x2, x1 plus y1, x2 plus y2. And scalar multiplication is a into x1 comma x2 is equal to component wise. Question is that, is it a vector space? Is V a vector space? Yeah. Which property fails?
Field is same.
There is no problem with first one because already we've seen, it is working with the vectors. Whenever you deal with the first one deals with only order pairs. There is no problem. V plus with respect to addition is an abelian group. There is no problem. What is the problem which I face? Look at the second property. What is A? A is my scalar. Means complex scalar. Yes or no? A is my complex scalar. Therefore, whenever it is a complex scalar, what is my V? V is nothing but order pairs which are real order pairs. Means each component is an element in R. So therefore, when I take A is equals to, if I take A is equals to complex numbers, if I take F is equals to complex number field, what is my definition of second operation? Second operation. What is the second operation? You take any scalar, you take any vector. When you operate the multiplication, scalar multiplication, that should be a vector, right? That should be a vector, right? You give me any scalar, you give me a vector. That when you operate a scalar multiplication on them, you can have a vector. But the thing is, unfortunately, it fails to satisfy this property. Unfortunately, it fails to satisfy this property. Why? Because I can take A is equals to I, complex number. It's an element in a field. I can take alpha is equals to 1, 2. It is an element in V. What about this? A into alpha. A into alpha is equals to I into 1, 2. That means by definition, what is my definition? Using this definition,
I2.
yeah, I1, I comma 2I. Therefore, is it an element in V? Is it an element in V? What is V? R2.
Yes, yes.
What is R2?
Not
Yeah,
No, sir.
set of all order pairs, right? Each element should be a real number.
real number.
Each element should be a real number. Therefore, it is not a iota, it's not a real number, therefore it does not belong to V. Therefore, it's not a vector space. Therefore, in fact, it's not a function. Second property, second operation should not be defined. Second operation should not be defined. Therefore, it's not a vector space over a complex numbers. It is a vector space over a real field. Okay. Last example number 9. It is a field over a real field. F is my real field. If I take F as a real field, set of all order pairs with respect to real field is a vector space, no doubts. But if I define, instead of taking real field, if I choose my field as a complex numbers, if I choose my vector addition as a component wise addition, and if I choose my scalar multiplication as a component wise multiplication, now then one can say that F V cannot be a vector space over a field F means complex numbers. Therefore, it is no. It is no. Right? Suppose if you take this 11th one, suppose you take this V is equals to Z cross Z. F is equals to rational field. What is Z cross Z? What is my V? My V is nothing but set of all order pairs entries coming from the integers. So what is my vector addition? My vector addition is again component wise addition. Right? What is my scalar multiplication? This one, component wise. See, SAR says if I define a component wise addition, automatically it is a vector space. No, we have seen. Even though we have defined it as a component wise addition and component wise multiplication, it need not be a vector space. It depends upon the field also. It depends upon the field also. We have seen whenever you have defined f is equals to r, it is a vector space. When I define f is equals to r, it's not a vector space. Thing is same argument. Is it a vector space?
No, sir.
Yeah, which property fails?
Second property.
Yeah, right. So there is no problem with first one because Z is a integral domain. It is an abelian group, no problem. Right? So therefore, V with respect to addition is an abelian group. There is no problem with this. Right? Because it satisfies all the properties. Inverse of that x comma y is equals to minus x comma y. Identity element is 0, 0, and inverse of x comma y is minus x minus y. And all properties satisfies. There is no problem. Therefore, it's an abelian group. Okay. What about scalar multiplication? Is it meaningful scalar multiplication? No. Right? Suppose you can take a is equals to 1 by 2. Alpha is equals, suppose you can take 1 comma 3. What about a into alpha? A is nothing but 1 by 2. It's 1 comma 3. My addition multiplication is component wise multiplication. Therefore, using this 1 by 2 comma 1 and 1 by 2 1 by 3. Therefore, this is nothing but 1 by 2 comma 3 by 2. Is it an element of V?
No.
No, because set is one of the element which is not an integer. Therefore, it is not element of V. Hence, it is it fails to satisfy the second property. Therefore, it is not a vector space. Right? Suppose if I take this 12, if I take V is equals to rational numbers, my field as real field. Question is, vector addition is usual, component wise. Component wise. You have seen what is meant by component. Next, scalar multiplication is also component wise. Component wise. So question is it a vector space?
Yes, sir.
Is it yes?
Yes, sir.
Check once again.
No, sir. No.
No, no.
Okay.
Right? No. Right? Same. No, there is no problem with V is an abelian group. There is no problem with this. Is an abelian group, no doubt. Because it's a field actually. Q is a field. So there is no problem. So what is the problem with a face is second property. If I take A is equals to root 2, it is an element of real numbers, irrational number. If I take alpha equals to 1, 2, it's an element in V. What about A into alpha? Root 2 comma 1 comma 2. Therefore, root 2 into 1. But component wise multiplication. Root 2, root 2, 2. Therefore, root 2, 2 root 2. Is it an element in V? No. Why? Because each component should be rational number. Therefore, it's not an element in V. Therefore, it's not a vector space over R. Right? Question is, if I take this, the same idea, if I extend this idea, same idea, V is equals to Q cross Q, my field to be, set of all A plus IB, A plus B root 2. So is that A comma B are the rationals. Question is, vector addition is again a component wise. Scalar multiplication is also component wise. Question is it a vector space?
No, sir.
Why?
Same like above one, sir.
Yeah, give
We
me
are having the
give me
scalar.
counter.
In scalar, we can use rational numbers, sir.
Yeah, give me scalar.
This
Give me
A
scalar.
plus B, 1 plus 2 root 2, sir.
Okay. Or else I can take A equals to root 2. Yes, sir. Enough, right? A equals to root 2, enough, right? Root 2 is an
Yes.
element of F, right? If I take A
Yes.
equals to 0, B equals to 1.
Okay.
Therefore, it's an element in F, it's an element in V. What about, A dot alpha? Root 2? 2 root 2. Is it an element of V?
Irrational, sir. No, sir.
No. So therefore, it's not a vector space. Right? Even though, what you observe, even though we have defined the vector addition and scalar multiplication in usual way, they may not be a vector space. It depends upon a, field also. It depends upon vector space, also depends upon the field also, whatever field you are choosing. Suppose you can take this. V is equals to 0. R cross R. If I take F to V complex numbers, vector addition again, component wise, and scalar multiplication also component wise. Question is it a vector space? Is V a vector space?
No, sir. Again, second property.
Sir, in above example,
Yeah.
sir, in above example, root 2 is belongs to Q, F.
Root 2?
Root 2 belongs to F, sir.
Yes, because I can take A equals to root 2, B equals to, A equals to 1, A equals to 0, B equals to 1. A equals to 0, B equals to 1.
Okay.
Okay, if I take A equals to 0, B equals to 1, automatically it is an element of F. Okay. Yeah, question is V is a vector space or a field of? What is the question?
No, sir. Again, second property will not.
Yeah, what is the scalar? What is the vector? Give me.
I, sir. Scale.
Good. A is I. It's a complex number, no doubt. Give me alpha.
1,
1,
comma
2.
2, sir.
Enough. It's enough. Right? A into alpha. I into 1, comma 2. It's a component wise. Therefore, I into 1. I comma 2. Therefore, this is I comma 2R. Is it an element of V?
No.
No.
No,
Therefore,
sir.
it is not a vector space. Right? So I think you understand what is a vector space, right? So it depends upon operations, it depends upon a vector addition operation, it depends upon a scalar multiplication, and even though they're right, they are beauty, they are in a beauty order, even though they are in a right order, it depends upon a field also. Right? It depends upon a field. Whatever field you are choosing, that is very, very important. So this is about R2. Right? Suppose if I take this, see, there are so many arguments you can choose. Suppose we take this, V is equals to, what I choose is, x1 comma x2, such that x1 is non-negative. What is my F? F is equals to R. Question is, vector addition is again, usual, component wise. So scalar multiplication again is a component wise, usual. Question is it a vector space? Anybody?
No.
No, sir. If scalar is 0, we will not go.
Yeah, which one fails to, which one property fails to?
Second, sir. Scalar multiplication. If scalar is 0, we will not get, sir.
Scalar is?
If we take our scalar as 0,
Okay.
then when we do vector multiplication, we will get
Scalar multiplication, not vector multiplication. Scalar multiplication.
Yes,
Hmm.
scalar multiplication. Second term will be 0. No, sir. Sorry, x1
I
will
don't
be
bother
0.
about
no.
second term. I don't bother about second term.
Yes, sir. First term.
I'm restricting about only first component. I don't bother about x2. X2 is a real number. X2 can be anything.
We take scalar negative value, sir, then it fails.
Yeah, what is that? If I take this, suppose if I take alpha is equals to 1, 2, is it an element of V? Yes, because first component is positive, right? Question is, does it have an inverse? Does there exist inverse? Such that alpha plus minus alpha is equals to 0. Does it have an identity element? In
No,
fact,
sir, no.
identity element with respect to addition.
No.
No, addition. If I take 0,
Zero,
0.
sir, zero.
No problem, right? Where x1 is non-negative, what you get it? x1 plus 0, x2, plus 0. That means x1, comma x2. There is no problem, right? But no, 0 is an identity element. Question is, does it have an inverse? Suppose if I take alpha equals to 1, 2, does it have inverse? No, right? No, right? Suppose if it has an inverse, suppose you take this. So what is minus alpha? Minus 1 comma minus 2, right? Question. So alpha plus minus alpha is 0. Okay, but the thing is, what is this? Is it an element of V? Is minus alpha is an element of V? No, right? No. Minus 1 is negative, right? What is my V? V is nothing but a set of all components, set of all order pairs in which first component is non-negative. This first component is non-negative, right? What is this minus alpha? In minus alpha, what you get is, minus 1 is there. Therefore, it fails to satisfy that inverse property with respect to addition. If you take alpha equals to 1, 2, there is no inverse with respect to addition. Therefore, it fails to satisfy the abelian group property. Therefore, it is not a vector space. In fact, does it satisfy the scalar multiplication? Anybody? Okay, it is not it's not a abelian group. In fact, not a abelian group. Question is.
No, sir. If a
Does it
scalar is a
satisfy-
negative number, no, sir.
Yeah, right. Same idea. If you take a equals to minus 1, alpha to be 1 comma 2, it is an element of V. What about alpha? A into alpha. A into alpha is equals to minus 1 minus 2. It does not belongs to B because it is negative. Therefore, it is not a vector space. Is it clear? Suppose if I take this 16th. Suppose you can take anything. Suppose you can take x1 comma x1 into x2 equals to 0. Suppose you take this. Vector addition is usual addition. Usual. Scalar multiplication is again same component wise. Usual. Question is it a vector space? Anybody? Any guess? For a field, what is my field? F is R realms. Not. Yeah, is it a vector space? Anybody? Any idea? What is my V? V is nothing but set of all order pairs from R to such that x1 x2 is equals to 0. That means x1 x2 equals to 0 means x1 comma x2 such that x1 x2 0 means what? Either x1 0 or x2 0. Yes or no? Yes or no? Yes. Suppose if I take means your vectors are either on x-axis or on y-axis. That is my vector space V. What is my V? You are on the y-axis or x-axis. If I take x1 is 0, you are on you are on y-axis. If I take x2 is 0, if I have an x-axis. Suppose I take alpha is equals to 1 0. Is it an element of V? Yes, because x2 is 0. If I take beta is equals to 0 comma 2, is it an element of V? Yes. Question is, does that addition is an element of V? What is my addition? Usual addition.
No, sir.
No. Right? 1 plus 0, component wise, usual. 0 plus 2, that means 1 comma 2 does not belongs to V. So it fails, it is not closed with respect to addition. In fact, V is not closed. It fails to satisfy the closure property, or V is not closed with respect to addition, vector addition. So hence it is not a vector space. Is it clear? Right. Suppose if you can do wonders. Suppose you take this V equals to R2. In fact, V equals to R. I'm going to restrict the components. X1 comma X2 such that X1 into X2 is positive. We have seen 0. Once it is positive, my field is R2 or question is vector addition is usual and scalar multiplication is also usual. Question is it a vector space?
No, sir.
Why?
అంటే అది ఇన్వర్స్ ఎగ్జిస్ట్ కాదు విత్ రెస్పెక్ట్ టు ఎడిషన్.
Yeah, inverse exist కావాలంటే first G additive
Both are
element
either
first.
positives or both are negatives.
The question is first of all inverse exist కావాలంటే first identity element ఉండాలి కదా, ఉంటుందా? Does it have an identity element with respect to ఉండదు, కాబట్టి అవసరం లేదు కదా ఇన్వర్స్ గురించి. ఎసాను ఇన్వర్స్ ఎప్పుడు మాట్లాడతాం ఐడెంటిటీ ఉంటేనే, ఎసాను కదా. సో దర్ఫోర్ ఇక్కడ ఫస్ట్ ఆఫ్ ఆల్ ఇది క్లోజ్డ్ అయిద్దా? నో ప్రాబ్లం, దర్ ఇస్ నో క్లోజ్, V with respect to addition is closed. ఎసాను there is no problem, right? Is there any problem? X1 X2 is 0, X10 X2 positive means, is there any problem with closure property?
Yes, sir.
Is there any problem with closure property?
No, sir, no.
Suppose you take X1 comma X2, you take Y1 comma Y2. If you take the sum X1 plus Y1, X2 plus Y2. Question is, does it mean that 2's product is positive? X1 is in V means what? It is X1 X2 is positive. Y1 Y2 also positive. Yes or no? So does it mean that X1 plus Y1 into X2 Y2 is also positive?
Yes, sir.
Yes or no?
Yes.
No need, sir. No need.
Yes or no? Yes or no? No means you need to give a counter.
ఇప్పుడు
Sir, 1, 2 minus 3 comma
Huh?
1.
1,
1, 2
2
minus 3
minus 3 comma minus 1. Okay. So what happened this sum? What about the sum? Minus 3,
Minus 2.
2 comma minus 1. Therefore, what is this?
Minus
3 minus 4. No, their product is negative, right? Because no need to have this X1 X2 Y2 and Y1 YX2 is positive. Understand? X1 X2 is positive, Y1 Y2 is positive. There is no condition on X1 Y2 and Y1 X2. Therefore, it need not be positive. Therefore, it is a counter. You can take this. Therefore, it fails to satisfy the closure property, in fact, with respect to addition. Yes or no? Is it okay? Hello?
Yes, sir.
Yes, sir. Yes, sir. Sir, directly with identity element it is enough.
Sometimes by checking it is a vector space or not is okay. So suppose it does not satisfy the identity property, okay. But the thing is, in GATE 2012, which property fails? They ask scalar multiplication property or closure property or additive property or something else. So you need to have in all possible cases. You need to check in all possible cases. Identity property direct ఇవ్వాల్సిన అవసరం లేదు. స్కేలర్ ప్రాపర్టీ కూడా ఫెయిల్ కావచ్చు, నెక్స్ట్ క్లోజర్ ప్రాపర్టీ కూడా ఫెయిల్ కావచ్చు. ఏదైనా 2012 క్వశ్చన్లో ఇచ్చాడు, నేను చెప్తాను తర్వాత క్వశ్చన్ పంపిస్తాను. బట్ ద థింగ్ ఈస్ అన్ని చెక్ చేసే లాగా మనం ఉండాలి. దట్స్ వాట్ మై పాయింట్, రైట్? చూడంగానే ఐడెంటిటీ ప్రాపర్టీ ఫెయిల్ అయిద్దని మనకు చూడంగా తెలిసిపోతుంది. బట్ ద థింగ్ ఈస్ ఇక్కడ వాడు ఐడెంటిటీ ప్రాపర్టీ గురించి అంత ఈజీగా ఇవ్వకపోవచ్చు. బట్ ద థింగ్ ఈస్ క్లోజర్ ప్రాపర్టీ ఇచ్చింది అనుకోండి, ఏమైంది? అసోసియేటివ్ ప్రాపర్టీ ట్రూ అయిద్దా? మరి అసోసియేటివ్ ప్రాపర్టీ ట్రూ అయిద్దామా? నేను ఇక్కడ క్లోజర్ ప్రాపర్టీ చెక్ చేశాను. అసోసియేటివ్ ప్రాపర్టీ ట్రూ అయిద్దాం.
No, sir.
ఫస్ట్ క్లోజర్ ప్రాబ్లం వచ్చినప్పుడు హౌ కెన్ యూ టాక్ అబౌట్ అసోసియేటివ్ ప్రాపర్టీ కదా? క్లోజర్ ప్రాపర్టీ అసలు అసోసియేటివ్ ప్రాపర్టీ అంటే ఏంటి? ఫస్ట్ దట్ షుడ్ బి బైనరీ ఆపరేషన్ సాటిస్ఫైయింగ్ ద ప్రాపర్టీ a plus b plus c is equals to a plus b plus c, రైట్? ఎస్ నో?
Yes.
ఇక్కడ క్లోజర్ ప్రాపర్టీ ఫెయిల్ అయినప్పుడు అసోసియేటివ్ గురించి మాట్లాడొచ్చా? హలో,
No, sir. No.
ఎనీబడి? నో ఆర్ ఎస్?
Same, sir. Like this examples we
No,
can
sir.
take. And
నో రైట్. ఇక క్లోజర్ ప్రాపర్టీ ఫెయిల్ అయినప్పుడు ఈ బ్రాకెట్ కు మీనింగ్ ఉంటుందా? ఈ బ్రాకెట్ కు మీనింగ్ ఉంటుందా? ఈ బ్రాకెట్ కు మీనింగ్ ఉంటుందా? అసలు ఇది ఎక్కడ ఉంటుందో మనకు తెలియదు కదా. క్లోజర్ ప్రాపర్టీ ఫెయిల్ అయింది కదా. ఈ ఎలిమెంట్ ఎక్కడ ఉంటుందో మనకు తెలియదు కదా. ఆఫ్ కోర్స్ ఈ ఎలిమెంట్ కూడా ఎక్కడ ఉంటుందో మనకు తెలియదు కదా. therefore how can you define this? ఈ ఎలిమెంట్ ఎక్కడ ఉంటుందో మనకు తెలియనప్పుడు how can you define this sum? Yes or no? So that's what my point. Therefore no need to check associative property. Yeah, okay. Suppose ఇది క్వశ్చన్ నేను ఇట్లా ఇచ్చాను అనుకోండి. ప్రాబ్లం నెంబర్ దిస్ 18th. ఇప్పుడు b equals to suppose x1, x2 which in R2 0 ఇచ్చాం, పాజిటివ్ ఇచ్చాం, నెగిటివ్. ఇది అయిద్దా? usual. Scalar multiplication also usual. Thing
No,
is
sir.
it a vector space? Yeah, which property fails?
First property. Closure.
Yeah, give me alpha, beta.
1,
no
2, 3,
identity.
4. 1, 2, 3, 4.
No, 1 2 3 4. See, నెగిటివ్ కావాలి, కాంపోనెంట్ చేస్తే నెగిటివ్ కావాలి. ఒకటి పాజిటివ్ ఉండాలి.
Sir, identity element property లేదు.
ఫస్ట్ ఐడెంటిటీ మాట్లాడాలంటే ఆ క్లోజర్ సాటిస్ఫై అంటున్నా. ఆఫ్ కోర్స్ ఇట్స్ నాట్ వెక్టర్ స్పేస్, ఓకే, బై లుకింగ్ ఎట్. బట్ ద థింగ్ ఇస్ క్లోజర్ ప్రాపర్టీ మాట్లాడాలని ఐడెంటిటీ ప్రాపర్టీ ఎట్లా మాట్లాడతారు? ఆఫ్ కోర్స్ 0 does not belongs to be, okay, but it's a right answer. Thing is does it satisfy the closure property?
No, sir.
Yeah, give me counter. What is alpha, what is beta? x1 x2 positive negative means what? At least one of them is positive, at least one of them is negative, right? Both have different signs.
1 minus 2, 3, 4. 3 minus 2.
1 minus 2,
3 minus 2.
2 minus 1, right? You take alpha beta is equals to 3 minus 3. ఏ ప్రాబ్లం లేదే దీనికి. నెగిటివ్ వస్తుంది కదా, నెగిటివ్ వస్తుంది కదా. మరి ఆల్ఫా ఇంటూ దిస్ ఇంటూ దిస్ ఏమైంది? నెగిటివ్ అవుతుంది కదా. యా,
అక్కడ పాజిటివ్ తీసుకుంటే ఏమైనా కాదు సార్.
సపోజ్ యూ కెన్ టేక్ -0.1 కదా. సపోజ్ యూ కెన్ టేక్ -0.1. ఇప్పుడు దీంతో ఏమైనా ప్రాబ్లం ఉంటుందా? ఇక్కడ చేంజ్ చేయండి, ఒకటే కాంపోనెంట్ దగ్గర చెక్ చేయకండి, ఇక్కడ చేంజ్ చేయండి. యూ నీడ్ టు చెక్ దిస్. ప్రాబ్లం విత్ దిస్, దేర్ ఇస్ నో ప్రాబ్లం విత్ దిస్ సెకండ్ కాంపోనెంట్. ఫస్ట్ కాంపోనెంట్ చేంజ్ చేయండి. ఫస్ట్ కాంపోనెంట్ ఏం చెక్ చేస్తారు? -0.2 తీసుకోండి. ఓకే, of course it is an element in V, no doubt, because the product of component is negative. What is alpha plus beta? 0.8 here -1 కదా. ఇచ్చాను. బట్ ఇది కూడా అందులో వీలో ఉంటుంది కదా. వీలో ఫెయిల్ అయ్యేటట్టు ఇవ్వాలి కదా. నేను ఇటు గివ్ డిఫరెంట్. ఇది కూడా ఫెయిల్ అవుతుంది కదా.
In place of 1, we have to take 3, sir, then it fails.
What is alpha? What is beta? See, this is -1
Beta,
కదా.
beta minus 0.23. తీసుకుంటే ఫెయిల్ అవుతుంది.
What is beta?
Minus 0.23.
-0,2 -0 na.
Yes,
0,2
sir, minus 0.2, 3.
alpha.
Beta, sir, beta.
So -0.2, 3. ఇక పాజిటివ్ వస్తుంది, ఇక పాజిటివ్ వస్తుంది, ఫెయిల్ అయిపోతుంది కదా. This is 0.8, this is 1. Therefore product is positive. Therefore it does not belongs to V. Therefore it fails to satisfy the closure property. Therefore it's no. Okay? Yeah. If I take a different restriction, this is 18, 19. Vector addition is usual. Scalar multiplication also usual. If nothing I mentioned means it is usual. You need to understand. Nothing I am given means you need to understand it is usual. Question is it a vector space? V equals to R2. Set of all order pairs. That's a circle. Unit circle. Center at the origin. Question is it a vector space? Why?
Identity element of model.
First, does it satisfy the closure property?
No, sir.
No, right? Why? No, why, right? Why?
Because they gave the condition as x1 square plus x2 square. So for that, we have to take any one as 0.
Yeah, x1 is equals to 1, x2 equals to 0, and if you take x2 equals to 1, x1 is 0, both are elements in S, V, vector V. Now alpha equals to 1, 0, it is an element in V. B equals to beta is equals to 0, 1, it is an element in V. What is alpha plus beta? 1 plus 0, 0 plus 1. Nothing but what 1, 1. Should not, is it an element of V? No, right? So what is the element you are, in order to say that something element which is in R2 means that should be in a circle. That should be in a circle. Is it an element of circle? No. In circle, no. This is 2, 2 not equals to 1. Therefore, it does not belong to V. Therefore, it is no. Is it clear? Yeah. First, చూడంగానే ఓకే ఐడెంటిటీ ప్రాపర్టీ అని అనిపిస్తుంది కానీ యాక్చువల్గా క్లోజర్ ప్రాపర్టీ లేకుండా దెర్ ఇస్ నో ప్రాపర్టీ ఐడెంటిటీ ప్రాపర్టీ. అది ఇంపార్టెంట్. కోర్స్ ఇది చూడంగానే ఇట్స్ నాట్ వెక్టర్ స్పేస్ ఓకే బై లుకింగ్ ఇట్ డజంట్ హావ్ ఎన్ ఐడెంటిటీ ఎలిమెంట్ ఓకే బట్ ద థింగ్ ఈస్ if there is no binary operation, if there is no closure property, no, you don't need to talk about identity property or inverse property. In fact, associative property also. Yes or no? Is it right or not? Suppose you take an ellipse. Suppose you can take vector addition usual. Scalar multiplication also usual. Question is it a vector space? My field is R. Or a field R. చెప్పండి అమ్మా. Yeah. What is this? What is this?
Ellipse.
Yeah, what is this? You take y equals to 0, x equals 0 means 0, root 3, 0, minus root 3. Yeah, question is, now does it, this is an element in V, of course. This is an also element in V, okay. Question is, does the sum, if you take alpha is equals to root 2, 0, beta is equals to 0, root 3, really they are elements in ellipse, Question is, what about alpha plus beta? Root 2 plus 0, 0 plus root 3. That means root 2 coming root 3. Yes or no?
No, sir.
Yes?
Sir, sum
Not
is 2.
close to sir.
Is it close or not?
No, sir.
Not
No,
close.
right? Because root 2 whole square by 2, root 3 whole square by 2 by 3 means this is 2 by 2, 1. This is 3 by 3, 1. This is equals to, which is not equals to 1. Therefore, it fails to satisfy the closure property. Therefore, it is no. Suppose you take this 21.
Sir,
Yeah. Yeah. No. Oh, sorry, sir. Time is on.
కంటిన్యూ చేస్తారా సార్?
మీరు తీసుకోండి సార్, మీరు తీసుకోండి.
వాళ్ళకి కూడా ఏమైనా వర్క్ ఇచ్చేదంటే హోంవర్క్ చేయండి సార్, ఒక 2-3 ప్రాబ్లమ్స్ అన్నట్టు.
ఓకే సార్.
నెక్స్ట్ ప్రాబ్లం ఇచ్చేసేయండి.
ఓకే సార్. Set of all order pairs. Suppose you take a parabola. Same vector addition is same. Scalar multiplication also same. Usual. Nothing I am given means you need to understand that is unusual. Question, is it a vector space? 22. Suppose you take this x1 comma x2 set of all other pairs, means you take a straight line x plus y equals to 1. Question is it a vector space? So vector addition is same. Usual. Scalar multiplication is same. Question, is it a vector space? Suppose you take this set of all other pairs such that a line which is passing through origin like x equals to y. Question is vector addition is same, scalar multiplication is same. Is it a vector space? Right? Suppose you take this 25 v is equals to set of all order pairs such that x by y equals to 1. It equals x by y, you need to understand x by y equals to 1 amma. ఇది ఏంటి x equals to y రెండు సేమ్ అనుకుంటారు కానీ కాదు. x by y equals to 1, x equals to y. ఈ రెండు డిఫరెన్స్ ఏంటి చెప్పండి. x by y equals to 1 ఇక్కడ x means here xy x comma y అనుకోండి. This x comma y, x comma y. You take this x comma y. This is x comma y. This is also x comma y. X comma y. Yeah. Tell me, ఈ రెండు ఒకటేనా? ఈ రెండు సెట్స్ కాదు, రైట్? ఇక్కడ మీరు అబ్జర్వ్ చేస్తే ఇందులో జీరో వెక్టర్ ఉండదు, ఈ సెట్ లో జీరో ఉండదు. Right? X by y equals to 1 means what? X by y, see any element you take in V that satisfies x by y equals to 1. That means it is non-zero, right? So 1 is non-zero. Means what? X by y is non-zero. But you are in R2. Means x is in R, y is in R. That means what? X into y, 1 by y is non-zero. R is a field. It has no zero divisors. That means x is non-zero. 1 by y also non-zero. Right? That means x is non-zero, y is non-zero. Right? So therefore it doesn't have a zero. Right? So therefore, but here ఇక్కడ 0 ఉంటుంది. Yeah, ఇవి చెక్ చేయండి. 25 problems are completed.